Okay, so hi everyone, welcome. My name is Diane Knispel. I'm the Director of Education at the Park City Museum. Welcome to our lecture series. This lecture is going to be done by the Friends of Ski Mountain Mining History. So at this point, I'm going to turn it over to them and let them introduce our lecturer. And for future lectures for the Park City Museum, please just check our website for updates. We update it as soon as we get information and we can put it on there. So with that, Sally, would you like to take over?
I'd be happy to. Welcome everybody. Donovan Simmons put this lecture series together a number of years ago, and it's focused on mining and our mine structures. And tonight we are very privileged to have Brian Buck, a resident of Park City, member of the Park City Museum and Friends of Ski Mountain Mining History. He has degrees in geology and geological engineering and 44 years of experience working in the mining industry in the US West. And his avocation is history, and he's just found a new career because he's a wonderful historian. And with him tonight is Clark Martinez, fourth generation Park City miner, worked in the Ontario mine, the Keatley Tunnel, and the Snake Creek Tunnel. He's a licensed contractor and owner of the excavation company and has worked on over 1,000 abandoned mine closure projects, including capping the Daly West shaft when it collapsed. So tonight, these two astute lecturers are going to tell us how and why the Daly West collapsed. And we've just received wonderful news that it's very likely it will be raised about the first week of August. A collaboration between Deer Valley, Park City, and Municipal and the Empire Master Owners Association will be collaborating to put this together. So Clark and Brian, welcome to you both, and thank you for agreeing to explain to us what happened.
Thanks, Sally. Clark, I'm not sure being called astute is a compliment. I'm not sure what astute means, but...
An astute historian, because you're correct and you check your facts.
Sounds like a compliment to me.
Okay, we'll take it, Clark, thanks. All right, in this lecture, Clark and I worked together on preparing the information that we're going to present to you. And thanks, Clark, for sharing your company records with us, and so we can share it with all the attendees. Very generous of you. And in this lecture, we're going to be describing the response to the collapse of the Daly West shaft and headframe that happened in May of 2015. And please hold your questions and we'll answer those at the end of the talk. So I'm going to go ahead and share my screen now. Does that look okay, everybody? So again, this is what the shaft headframe looked like after the collapse. So a little bit of information on the location. Many of you I know where the Daly West shaft and headframe are located, but let's look at this photograph of the Montage Hotel. What you see here is Upper Empire Canyon, taken from a drone uphill of the Montage Hotel. And you see Marsac Avenue, Upper Marsac Avenue that comes up. Here's the roundabout at the Empire Canyon Lodge, and then the road continues on over to Guardsman's Pass. And here is the Empire Canyon Lodge. This is the Empire Express lift, ski lift, and of course, the Montage Deer Valley Hotel. And this feature right here, just uphill from the hotel, is the Daly West shaft and headframe. So let's talk a little bit about headframes and kind of get up on the same level if we can. If you visit any of the old mining sites in the Western US, you may encounter mine shafts. And these are readily apparent if the surface facilities are still present. This photo shows a typical layout of an old shaft facility. Now, this tall frame structure is called a head frame. And old head frames were built of wood timbers, just like this one. Now, the vertical front legs of the head frame straddle the shaft opening, which is at the base of those front legs. And it supports the vertical guides that you see sticking out of the ground here that were for the elevator compartments, which in mining parlance are called cages. And if the shaft is used to transport rock in buckets, those buckets are called skips, and they're specially made to ride up and down on the guides in the shaft. And the skips or the cages are suspended on steel cables that are called in the business ropes, hoist ropes. And they come up out of the shaft and over a pulley at the top of the head frame that is called a crown sheave or a crown wheel. And then the cable goes back down to a hoist house. And inside that hoist house is the winding mechanism to pull or release that cable. And of course, that equipment is called the hoist. Now, these angled back legs of the head frame help support the weight of the loads coming up the shaft, but also it counteracts that pull from the top of the head frame back to the hoist. So here's another picture of an old shaft and head frame, including all the same features that we just discussed in the previous one, except this head frame is newer and it's made of steel. The front legs straddle that shaft opening, and you can see the shaft framing extending on up vertically along those front legs from the shaft. The hoist ropes are visible leading from the hoist house to the crown sheave and then down the shaft. And the back legs angle from the top of the head frame back towards that hoist house. Now, head frames and shafts are not just historical items. They're still very much in use today in the business. This photo shows a modern mine in Canada with two enormous head frames, of course, built of steel. The one to the left that is covered in blue sheathing has all the same basic components of the historic head frames we just talked about. The front legs are covered inside the building, but you can see the crown sheaves at the top. You can see the angled back legs. The large hoist house and the cables going into the hoist house are all quite evident. And the head frame under construction on the right is 15 stories high and not yet fully enclosed, as you can see. Note the workers on the ground for scale of this facility. In cold climates, head frames are typically enclosed in buildings, which, by the way, was the practice on most of the historic head frames in the Park City mining district. Now let's focus on the Daly West shaft. It was started by the Daly West Mining Company in the early 1890s and eventually sunk to a total depth of 2,100 feet. The original wood head frame and hoist house was destroyed by a fire in 1913 and replaced by an 85-foot tall steel head frame in 1914. This photo shows the 1914 head frame and supporting facilities. Note the bottom of the head frame and the shaft were enclosed in a building. This is the same head frame that currently occupies the Daly West shaft site. This photo shows the interior of that building. One of the front legs of the steel head frame you can see here on the left side of the photo. And there are two shaft compartments visible in the floor of the building, with a cage for the left compartment stopped at the surface, and you can see a mine car in the cage. A cage was basically an elevator platform without walls that was lifted up and down the shaft with hoist rope. Miners would crowd onto the cages to go in and out of the mine, and mine cars lifted up and down the shaft.
Kind of cool. Here we can sit on the beach in Maui, looking at Lanai.
You can see the rails leading away from the shaft where the cars of ore or waste rock could be pushed away from the shaft. In the picture, the right-hand compartment and the cage in the right-hand compartment must be in motion because you can see in the photograph the ghostly outline of that hoist rope moving quickly. Note the only safety device at the shaft station are these single hinged bars that can be raised for each compartment. Check out how casually that one worker is leaning on the safety bar next to a 2,100 foot deep hole in the ground. Just shows you can get used to anything. The shaft continued to be used for mining purposes until the early 1980s, and then was owned by the Jordan Special Services District, or JSSD, to provide ventilation for their collection of the groundwater draining from the mine tunnels that connected underground to the shaft. Sorry about the poor quality of this photo, but it shows the condition of the site in about 2007, when the Montage Deer Valley Hotel was being built, and the shaft was already surrounded by the Deer Valley Ski Resort. The 1914 vintage buildings from the previous photographs had already been removed, and a more modern hoist building and equipment had been installed. Most notable is that the shaft is no longer protected from the weather with a building. The shaft and that modern hoist house continued to coexist with the ski resort and the nearby hotel. The shaft was surrounded by a tall fence to keep people away. And here you can see the head frame proudly standing and the Montage in the background. Security wire fencing was installed around the top of the shaft framing to provide for safety of visitors within the site. And so you can see this chain link fence has been installed on the guides coming up out of the shaft. The shaft opening itself was surrounded by a concrete pad or collar. And this picture shows the same front legs and the same cages that you saw in the earlier photograph. Now let's talk a little bit about the underground aspects of shaft design. Modern shafts are typically round and equipped with concrete liners, but the old shafts were generally rectangular and equipped with timber supports. This picture shows the design of timber framing in a shaft. Timbers were used along the sides of the rectangular shaft opening and also on the ends. And if it was a multiple compartment shaft, as you see, this one has two skip compartments and a cage compartment, as well as a manway. And those were divided by divider timbers. Now these timbers, each one of these frames was called a set. And these timber sets were horizontal structures like this that were placed in the shaft and firmly locked into place with wooden wedges driven between the rock walls and the timbers. And you can see in this picture of the wedges that do that. Now these sets would be regularly spaced all the way down the shaft, and a deep shaft could have hundreds of these timber sets in it. Hung vertically across the sets then were the guides for the skips and the cages to run up and down. And you can see these guides installed on the sides of these compartments in this drawing. Most shafts also had a manway off to the side with ladders for emergency access. And this is where pipes for compressed air and water and electrical conduits were also located. Now, these timber sets rather, were requiring a lot of maintenance. And they required regular attention to reset the wedges holding them in place, and of course to replace any broken or rotten timbers. And this was a regular maintenance activity in these active mines to keep these shafts in action. And as long as this maintenance was taken care of, a shaft could potentially be perfectly serviceable for many decades. So here's a view down a single compartment of a rectangular shaft. Note these horizontal timber sets spaced equally all the way down the shaft. It looks to me like they're spaced maybe every 5 feet or so. Now, these timber sets, of course, support the rock sides of the shaft to prevent the rock from caving in, but they also support these vertical guides. And so here you can see the guides attached to the sets and going on down the shaft. And the cage or the skip would have fittings on them that ran along these guides so that they could securely locate the cage or the skip within the shaft as those features traveled up and down. Now you look at this picture, all the timber that we can see appears to be in relatively good shape, doesn't it? Here's a view down a different shaft. And you can see two compartments here. You can see the compartment right in front of the camera, and off to the right is another compartment. You can see the vertical guides going on down the shafts. You can see, of course, the timber sets. And like before, the condition of the timber in this shaft, again, seemed to look okay. Here we're looking down what appears to be a single compartment shaft. And note the boards here behind the sets. And these boards are called lagging. And they suggest the need to hold back some unstable earth from falling into the shaft. And this is a common feature of the upper parts of many old shafts, because the earth from the ground surface down to, in many cases, tens of feet in depth, is pretty much soil and not rock. And so that soil needs to be held back so it doesn't fall into the shaft. And the soil was held back with this continuous shaft lining until you got down to the bedrock. Again, the timber and the lagging in this shaft appear to be pretty sound. Now, as I said before, timber shafts require care and maintenance. And once a shaft is no longer in use and the maintenance stops, timber sets and lagging change over time. The timber sets may loosen and become deformed, as seen in this view down the old shaft. Can you see way down there? Some of the sets are starting to give way. Loose sets and guides and other parts of the shaft may begin to fall out of place, and then the rock and the earth held back by the timber is also free to fall down the shaft. And this is the fate of any shaft that does not receive regular maintenance. Eventually, rotten timber sets and lagging can endanger the stability of any shaft with potential collapse eventually. Look at the poor condition of the timber in this shaft as we look down to where the lagging is rotting away and the material behind it is beginning to ravel and fall into the shaft. Here, it looks like an emergency recovery worker is possibly risking their life going down the shaft, possibly looking for a potential victim of a fall down the shaft. And unfortunately, this can happen when unwise visitors to old mine sites get into unsafe conditions. This photo demonstrates the wisdom of moving carefully and watching where you step at any old mine site. Now, some shafts are sunk from the ground surface down in solid rock. So even when the timber sets loosen and fall down the shaft like they have here, the shaft opening is still pretty much stable for the long term, but dangerous as all get out. However, this is not the case for shafts where the top portion of the shaft is sunk through loose earth that is seasonally wetted by snowmelt and rainwater, further weakening it. When the timber sets and the timber lagging begin to fail in these situations, the timbers as well as that surrounding earth begin to fall into the shaft. And the loose earth cannot hold a vertical slope, so it sloughs into the shaft until a crater is formed that is much wider on the ground surface than the original shaft opening. So you can see these openings are extremely dangerous to approach for obvious reasons. Now, because of these safety concerns, the state of Utah Division of Oil, Gas, and Mining has been closing abandoned mine shafts and tunnels for years. And Clark has a lot of experience working on those projects. In some cases, an open shaft is simply backfilled with earth from the bottom up. In other cases, a plug or a cap is set in the upper part of the shaft. And that plug is set ideally just below the contact between that weak soil, earth, and solid bedrock. And a cap is constructed to close that shaft across that weak earth. The potentially unstable upper part of the shaft is filled with lightweight polyurethane form, also called puff, P-U-F, to support that weaker ground so it does not cave in. The foam is placed as a liquid, and it rapidly expands to a strong solid that forms itself to the surrounding shaft opening. And in certain cases, a vertical culvert might first be set through that upper part of the shaft, and then it's locked in place by the foam to provide access into the shaft through that cap. And then the top of that culvert is closed with a metal grate to protect public safety. This drawing is a typical foamed cap for a shaft. This is a typical design used by the state of Utah. And so here we see, this is the contact between the solid bedrock below and the weak soil earth above. And of course, the shaft is driven through all of that. And so a plug is placed down in the bedrock. And in this case, a culvert was hung down to that point. And the annulus, or the surrounding area between that culvert and the sides of the shaft, is then filled with puff. A concrete cap is placed on top of the puff. And then, of course, the top of that vertical culvert has a safety grate on it to prevent people from getting into it. And this is a typical design that the state of Utah uses. And Clark is very familiar with this. After the early 1980s, the Daly West shaft was only used for ventilation of those underground openings. And this purpose did not require regular use of the shaft hoisting equipment or maintenance of the shaft timbering. Clark thinks the last time that cage was lowered into the shaft was in about 2004. And even at that time, it could not be lowered all the way to the bottom, something blocked. In 2012, the unconsolidated ground on the north side of the shaft fence began to cave in, and it caused an opening up to the ground surface outside that fence. And that's what you see here in this picture. Clark's firm, the excavation company from Camas, Utah, specializes in closing these kinds of things. And they were hired by JSSD to fix this problem. The caved ground was excavated to expose where it was falling into the shaft. And that puff, polyurethane foam, was used to stabilize the opening. And here you can actually see the shaft timbers, the lagging, exposed in this excavation. The cave-in was filled almost to the surface with puff, and then a layer of concrete was placed on top of the puff, and then soil above that to the ground surface. Then a couple years later, in the fall of 2014, JSSD found that the soil on the other side of the south side of the shaft had caved in, similar to that one that Clark fixed. And they recognized at that point that a general repair of the upper part of the shaft was needed. And they began talking to the excavation company about that. But the onset of winter delayed this construction. And so that hole was covered with steel supports and tarps until spring. And the spring of 2015 was rather wet with snow melt and rain. The construction contract between JSSD and Clark's company was signed on Thursday, May 12th of 2015. However, at 7:30 a.m. the next day, Clark received a call from JSSD that Deer Valley Resort employees had just discovered this. The headframe had collapsed. The cave-in had expanded to a crater over 40 feet across and 35 feet deep that affected all sides of the shaft. In this photo, you can see that about half the front legs of the headframe were down in the crater, and the back legs were almost horizontal as it fell over. When the ground caved, the shaft, when the ground caved under the shaft, it undermined the footings of those front legs of the headframe, which caused them to fall into the crater. And that caused the entire headframe to tip towards the north. The concrete collar and the shaft structures that we saw in the previous photo, between those front legs were wrecked. and also present in the bottom of the crater. This debris and the loose earth that had caved in along with it actually tended to plug the shaft opening. And when the headframe fell into the crater, the front legs were seriously bent and the cross members were separated. And as the headframe fell, those back legs also separated from their footings and were also damaged. And you can see the kink in this one back leg. That should be straight. As the headframe toppled over, the cages ran up the guides to the top of the headframe where the crown wheels were. And of course, they suddenly stopped at that point. And this caused the cables leading back to the hoist to pull down parts of the hoist house roof and walls. And that's what we see here. Now, Clark's company, the excavation company, teamed up with Spectrum Engineering to conduct the required work. And Spectrum and their structural engineering subcontractor, Criven and Associates, came up with a design to cap the top of the shaft that included 4 main components. A 3-foot diameter culvert would be suspended through the crater to the debris plug in the shaft to provide an opening down to that point. The very bottom of the crater, approximately the bottom 20 feet of the crater, would be filled with polyurethane foam. Then 2 30-foot long I-beams would be laid across the top of the puff, and 12 inches of reinforced concrete would be placed over the entire surface of the puff. And of course, it would be reinforced with reinforcing bars and would encapsulate the bottom of those I-beams. And then the remainder of the crater would be filled with earth. These plans for capping the shaft were reviewed and approved by the city and by the EPA. So an early step of the overall project was to lift the headframe out of the crater to clear the site for installation of that cap into the shaft opening. The headframe weighed 85,000 pounds, and it took 2 large cranes to carefully pick it up. The larger pieces of debris in the crater were also removed. You can see the 2 cranes working here. The headframe was laid down at a location immediately north of the shaft. And so here it is lying on the ground. And you can see one of the cages has been taken out of the crater as well and laid down on the ground next to the headframe. And see the size of the crater in the foreground of this picture that has taken out the fence. It was decided that the hoist house was too severely damaged to be repaired, and it really didn't have a use any longer. And so the hoist house was removed, and leaving the double drum hoist equipment behind and exposed to the weather. And here you can see the double drum hoist. And this is, these structures have been removed now, and that hoist is exposed to the weather. So here we go. A crane lifted the culvert to the vertical orientation and placed it down into the crater for installation of the cap. The bottom puff section of the cap was then placed in layers over a period of about 3 weeks to allow each layer of foam to cure to full strength. So here you can see the puff emplacement in the bottom of that crater. The I-beams and reinforcing steel were then installed on top of the layer of puff. And this photo helps to show the scale of that large crater that was being capped. Just look at the scale of all this ironwork. It's a big hole in the ground. The concrete layer was then placed on top of the puff, encapsulating the rebars and partially enclosing those steel I-beams to tie it all together. And the remaining crater was filled with clean earth, and a security grate was installed over the culvert. And this is what the shaft looks like today. Another crane was then brought in to pick up the head frame and lay it on its side within the site, and the wood fence was repaired. So all this work was completed in the fall of 2015, and the site has remained in this condition, essentially in this condition since then. But as Sally said, things are looking up for the Daly West head frame. The Deer Valley Resort acquired the shaft property from JSSD in 2020. The municipal government of Park City, the Empire Pass Master Owners Association, and Deer Valley Resort are now collaborating to fix the head frame and to raise it, as we heard in August of this year. Now, the engineers who designed the cap for the shaft recommended that the head frame not be placed over the shaft again. So the plan now is to fix the head frame and locate it just uphill of the shaft location, as you see here. So we look forward to being able to see this landmark of Park City's proud mining history once again standing tall. And it'll be more than 107 years after it was originally built and 6 years since it fell down. And this will be a most welcome and I think very appreciated gift to the community. So at this point, let us mention the work of the Park City Museum and its volunteer committee of the Friends of Ski Mountain Mining History. The museum and the committee are dedicated to saving the significant remaining mining structures around Park City and educating the public as to the rich mining history of the local area. And this presentation that Clark and I are doing is part of that education process. This slide shows a collage of projects that we have already undertaken. And don't have time to talk about all of these, although each one is fascinating in its own right. You can learn more about the mission of the committee and our accomplishments so far, and how you can support our work at the Park City Museum website. And the link is shown here, parkcityhistory.org. Major stabilization projects that are coming up are two of the remaining shaft facilities in the area. And these are the Silver King Coalition and Thanes shafts. We want to minimize the potential for these head frames to suffer the same type of collapse as what happened at the Daly West. The Silver King shaft is shown here. It is 1,300 feet deep, dates back to 1892, and was used for mining until the early 1950s. The shaft and the head frame are enclosed in this tall building, but you can see all these buildings are starting to fall down and they need to be stabilized. However, we first need to deal with stabilizing the shaft that is currently collapsing and threatening the head frame from collapsing itself. The Thanes shaft in Thanes Canyon was sunk to a depth of 1,750 feet between 1937 and 1939. So you can see it's a more modern facility. And this was used for mining until 1947. The shaft connects at depth with the Spiral Tunnel. And the Spiral Tunnel was driven into the mountain between roughly 1916 and 1924 from a portal on the north end of Park City. Now this steel head frame is exposed to the weather, as you can see, but the shaft opening itself is enclosed with a building. Unfortunately, the Thanes shaft is also collapsing underground, threatening the stability of this head frame and the other surface facilities that you see here. Now, the Thanes shaft is important historically, not only for its past use for mining, but also because of its unique use in the ski industry that was just beginning in Park City in the 1960s. Beginning in 1964, the Spiral Tunnel and the Thanes shaft were used as an underground ski lift for what was then called the Treasure Mountain Ski Resort. Skiers rode in a special train, as you can see here, they're loading up, and they would ride that train through the tunnel for 2.5 miles to the bottom of the shaft. At the shaft station in the tunnel, the skiers would leave the train, collect their skis, and were lifted to the surface where they stepped into their skis and skied down Thanes Canyon or took the Thanes chair to Crescent Ridge above the summit house to ski the other runs. This most unusual ski lift was operated seasonally for just a few years and has never been duplicated in all of North America and perhaps the world. There's a great exhibit of this underground lift, including some of the Spiral Tunnel train cars in the Park City Museum, and it's called the Skier Subway Theater. It's a fun place to learn about how this worked. Now, both of these projects are going to be expensive and will test our ability to obtain enough financial support, but we are motivated to prevent another headframe collapse like what happened at the Daly West. So if you're interested in helping support this important work, please get in touch with us via the museum website or by calling our committee's fearless leader, Sally Cousins Elliott, at 435-640-3759. And thanks so much for attending the lecture and for your interest in Park City's mining history. And Clark and I will be happy to answer your questions on this presentation if you have any. Thanks so much. Turn it over to you, Diane.
And Diane, may I say that once upon a time, Clark's father, Rich Martinez, the old miner, said that in the machine shop, he helped construct the cars that took the underground ski lift up to, from the Spiro Tunnel up to the Thanes shaft. What an amazing family you have, Clark.
Thank you, Sam. I'd like to mention too, I've got pictures of my grandfather driving the ski train. That was one of his jobs, hauling the skiers in on the train.
So your father and your grandfather, wow.
Yeah.
And your great-grandfather was a Park City miner as well.
Yes, he was. And in '78, I actually worked in the Daly West. We'd go down, we were on the 1,200 foot level rehabbing it so that they could, they were trying to get more air into the Ontario, and they were going to put a big fan down there on the 1,200 to help ventilation in the mine. So the Daly West, I have been in the Daly West and down the shaft many times back in the late 70s.
We have some amazing footage of traveling through the Judge Tunnel to the Daly West shaft and miners going through the Judge Tunnel to the Daly West shaft and up. It's amazing footage. We'll probably be able to share that with you by the time the Daly West is raised.
We do have some questions too, so I don't know who wants to answer them, but we've got one that says, will there still be a fence around the head frame once it's resurrected?
We don't know the details of that. The parties that we described are currently funded to do the work, and they're in the process of working with their engineers and contractors to come up with a design for that. But I'm not aware of what the design is exactly for what that site's going to look like when they get done with it.
Okay.
Yeah, Brian, this is Steve Isowitz from Deer Valley.
Hey!
Oh, there he is.
He might.
Sort of. Thanks for, that's a great presentation. It's really cool. So thank you for putting that together.
Thank you.
Super interesting. I see a bunch of the questions in the chat bar. So one of them asked about the cost versus, to stabilize this before it fell over versus after. Obviously the costs after are much more significant. Most of this, the funding, it's kind of been a compilation of entities. So Deer Valley stepped in to buy the ground just because nobody was really doing anything. And so to just secure it and make sure there was something that happened there, we did that. And then the Empire Master Owners Association stepped in sort of right behind. And while they were working on some development approvals and things, and the city, was involved in getting an agreement together to make sure that funding was put in place. So between the city, the Master Association, and the developers in Empire Pass, they put that fund together in an agreement to be able to resurrect this and straighten it out. So a lot of the costs involved are going to be really in fixing the metal itself, because the legs do need to be straightened and supported. I know a lot of the craftsmanship that went into the head frame back in the day, all those laced girders and the stuff that makes it look really cool. They're going to try and I think do their best to replicate, but obviously that's pretty hard to do. But once that's all straightened out to where it's structurally sound, then it'll go to the parcel that we've said that they can put it on just to the southwest of the head frame there, up above it. And for as far as fencing goes, because that was a question here, that part we have to figure out. We need it to be safe in a way that people can't climb it and have issues and major safety concerns around the resort property, as well as just on the structure itself. But we also want everybody to be able to see it and be able to view it like very clearly and closely. So we haven't really figured out how that's going to work yet, but I think that's something on our agenda. And the same goes for all the hoisting equipment and the stuff that's going to sit on the current site, which is we don't want that to really be covered up either. We want people to be able to see that. So something that we're all going to be collectively working on. And Sally's been a huge, as you all know, she's the one driving the horses here and making sure that we're all doing what we're supposed to. So it's been a fun one.
I haven't done anything but just say my heroes are here. Steve Isowitz actually put his career on the line to insist that Deer Valley buy the land. And without Steve's support, this never would have happened. Donald?
Yeah, Steve, I just, ironically, I sent Steve an email today to set up an on-site meeting in early June to talk about fencing, signage, et cetera, so that it's aesthetically beautiful when we get the head frame back up. To answer the question about, I have no idea what it would cost before or what Clark was proposing to do 5 years ago or 6 years ago when he had his contract, but they're estimating that this project now is going to cost in the neighborhood of $450,000. And we will need to bring up the two largest cranes in Utah to lift up the head frame and get it moved to the new concrete bed. But so it's not a minor undertaking to get this done. Clark, do you have any perspective of what the cost was 6 years ago to stabilize it?
When it failed in 2012, I gave him a proposal of $250,000 to go down in the shaft. My brother knew how to run the hoist, and we were prepared to fix the top 80 feet. But at the time, they thought it was too expensive. And so with nobody maintaining it, when it finally fell over, it cost about the same to pull it out of the hole and put the foam in and, cap it. But I think as long as you don't have constant maintenance, something was going to be done, because it's like the Ontario. Right now, the Ontario, they can only go down to 700 feet level and the cage stops. And in the Ontario, at that particular spot, it's a clay seam. So the shaft compartment wants to move to one side or the other. And it was a constant maintenance while the Ontario was running. So, eventually it's going to be a problem. But unless you constantly maintain them, unless that shaft, the hoist is running and they have a crew and every few years they go down and fix the wedges or do whatever, I think there is, the cost would be forever.
I think you answered one of the questions from Larry Hardebeck, I think. He said, can you tell us what the name of the mine shaft is where there was a commercial mine tour some years ago? And I think that was the Ontario #3 shaft, one you were just talking about.
Okay, thanks. I feel lucky I was on that tour.
You are lucky.
My wife wanted to go on it, but it closed a couple years later.
Yeah, I got to Park City too late to do that. Can you describe Park City Mountain Resort's involvement, financial and otherwise, in the Friends, I assume Friends of Ski Mountain Mining history and Deer Valley? We've had nothing but support from, Deer Valley and from Vail and Park City Mountain with what we're trying to do. Don, Raul, can you talk about that a little?
Sure. Well, Vail helped get us started back in 2015 when they took over the Park City Mountain Resort, when they purchased the rights to lease land. And they've contributed not only cash, but they've also provided us our First Tracks fundraising breakfast annually. Unfortunately, this year with the pandemic, we weren't able to do one, but hopefully that'll be back next year. Deer Valley, in addition to cash contributions, also hosts a hike with a sumptuous lunch for us every year. So we have a very strong relationship with both of the ski areas. And without whose support, we would not be as far along as stabilizing all the structures we've done, because they've been a major contributor of the cash for these projects.
May I say that Vail has contributed so far north of $250,000, $250,000 toward the stabilization, and their staff support has been amazing, as has the staff support of Deer Valley been. We have great support because I think everybody knows that part of the Park City brand is that you can ski past old mines and learn about mining history from skiing here. We have great support, both sides.
And biking and hiking.
Both.
Another question is from Chris Sammartino. The question is follow-up: cost for stabilization before, after for the other structures. Can this be a selling point for fundraising?
Well, we are,
we're on it.
Really good. That's a really good question. And we are just embarking on a capital campaign program for both the Silver King and Thames head frames, the shafts, the hoist buildings, etc. And the reason we need to go to the capital campaign route is we think that this could cost up to $3 million to stabilize those, the shafts, which Brian and Clark talked about earlier, and then do the remediation work on the actual structures themselves to ensure they're going to be here for another 50 to 100 years. So that's a lot of money. And, we are just embarking now on getting engineering studies, cost estimates, et cetera, from Clark's company, as well as Jonathan Richards, who's our primary engineer. We have Stantec, thanks to Brian. We've had Stantec do some preliminary work on the shafts, and Brian's also has a whole bunch of geological studies that are going to be done this summer to figure out what's going on underground, because we can't see. All we can see is that the structures are being pulled down by the subsidence of the shafts.
And may I also say that Rio Tinto Mining is providing LiDAR drone coverage support. They'd helped us do some initial engineering, and they're coming back to take a LiDAR survey down both shafts, which is amazing help from Rio Tinto. Yeah, so mining companies have lined up to support what we're doing, and I think they love the idea that we are preserving these old structures.
So as the old saying goes, stay tuned to the station for further details.
I think the last question we have here is from Tracy. Are there any other head frames on the mountain besides the three you mentioned? And we talked about the Daly West, and we've seen in the presentation that Clark and I prepared, we've got photographs of the Daly West, and we talked about the Silver King and the Thames shafts. There is another head frame still standing, and that's the head frame over the Ontario number 3 that Clark was talking about just a few minutes ago, and that Larry was lucky enough to take the tour some years ago before they closed that. That head frame is also standing. I don't think, Clark, there are any other head frames still standing. I mean, the shafts are all still there, but I think those are the head frames that are still standing.
Yeah, I think them are the only 4 left.
Yeah.
At one time there was probably 10, 12. I mean, there used to be a lot of them, I think.
Yeah, yeah.
And to me, it's a shame, especially the Ontario. I mean, it could still, the hoist runs, everything still works. JSSD still needs it to be viable. It connects the 1500, which comes outside of Keatley. You know, I don't know. Nobody can make JSSD maintain it, but it's a shame that they don't. You know, it's 150 years worth of work that hundreds of guys have, you know, pretty soon you won't see none of the underground workings of Park City, which is a shame.
There are lots of people who would like to see the underground workings, yep. And there are very few access points. If we have an enormous contribution to our capital campaign, then perhaps we can do something about that. But other than that, you know, all it takes is money, and we don't have any.
Yeah. And one of the reasons why Clark and I in our presentation talked about how these historic shafts were actually constructed is to educate folks to the fact that the timber sets that are in these shafts don't last forever. And in mountainous country where there's groundwater, the timber weakens, rots, the sets and the wedges can loosen up and things get displaced, and the structures down in these shafts begin to fall apart. And down in the solid bedrock part of the shafts, deeper down, that may not be as much of an issue as that upper portion of the shafts that we talked about. The upper tens of feet in the shaft where the lagging is holding back that soil, basically. It's not rock, it's unconsolidated earth. And when the structures in that portion of the shafts starts to let go, like we saw on the Daly West, then, you know, that's the ball game. That's when you get those craters forming, and it's a hazard. But if there's a head frame standing there, the head frame's coming down. So it's really the fate of any shaft, actually.
You know, I'm reminded one time on a tour that Jim Ivers took us on. That would be James Ivers III, whose statue is on Miners Plaza on Main Street. I said, well, George Thompson and Fraser Buck's book says that there's 1,586 miles of mine workings underneath Park City. And Jim Ivers said, no, I think it's only about 1,200. That's a lot of miles, folks. A lot of it is stopes that have been backfilled, but we are honeycombed underneath in our hard rock Park City by underground mining shafts, and it's underground mine workings. It's fascinating. And, you know, we're losing it.
Thanks, Dalton. Dalton has added a chat to learn more about Friends of Ski Mountain mining history, making a contribution, etc. Go to the museum website, and he has
ParkCityHistory.org. Mm-hmm. Thanks, guys. This has been wonderful. And all of my heroes are right here on the screen. Thank you for your support.
Good job, Donna, or good job, Brian.
Thank you.
And if any of you missed part of the presentation, we recorded it today. We will be putting it on our Park City Museum YouTube channel. And so you can see what you missed later on. So, and we usually do this, it'll probably be done by early next week. So, all right. Thank you all for coming. We appreciate it. And is there anything else before we?
I don't think so. Thanks, Dan.
Okay. Thank you. Thank you, Brian.
Yeah, thanks,
everybody. Okay.
Thank you. Thanks,
Good
Clark.
one, everybody. Good night. Let's see.